All right, so let's look at some of your friends' response over here and see what we can discuss from it. So we have from group 3, section 1. This is about flow control valve 0014. Okay, flow control valve 0014. There are 4 questions. Okay, there are 4 questions. Korang tak letak gambar. Okay, it's better if you can put some screenshot of this apa dia of this valve. Azri, can you do that? Or any other group members from
Boleh. Kejap.
okay?
Punya line tu tebal sangat. So tak nampak terlebih.
The same thing also with this group. Tak tahu group mana ni. Okay, the same with the process flow control valve 0014. Kalau boleh letak dia punya figure.
Saya sama group dengan Azri ke?
Sama ke? Azri mana satu? Ni ilmu ni sama juga F0014?
Kawan satu group.
Ada tak dia punya tu? Dia punya gambar? Mana ni ke? Okey, banyak ni korang ni.
Awak kena refine lah sebab dekat pic tak nampak. Tak pada masa tu awak refine
Okay, we look at this first. Flow control 0014. Okay, flow control 0014. This is normally the arrangement. The arrangement of the instrumentation relates with the flow control. Normally it is something like this. Okay, when you draw the control valve ataupun when you draw the control loops in your PFT, you do not include the other valves. Right? You just put there the control valve only, but not taking into consideration the other gate valve. The reason is because that's only relate with your control loops. The question is, when that we obtain this kind of configuration, this kind of structure, this kind of arrangement where you need to have several valves surrounding your control valve? Okay, the answer is after you do your safety analysis, especially the HAZOP. Okay, the HAZOP analysis, HAZOP. What is the full name of this word, HAZOP? Siapa tahu? HAZOP. You have taken the safety, the health, environment course, if I'm not mistaken. Okay. The HAZOP analysis is one of the safety method, okay, that you need to do for every single drawing, especially the PFD, the PNID that you have developed, that you have generated. Okay. So HAZOP is a short name for the hazard. Nope. It's not it's a hazard and operability study. That's the short name is HAZOP, HAZOP. HAZ for hazard and OP for the operability. All right, when you're talking about hazard and operability study or HAZOP study, you need to consider two parts The first part is on the hazard, more on the safety. And then after that, you look for the operability. So when we are talking about hazard, so we analyze every single equipment, every single thing that we have, especially when you do the markup. Okay, markup yang you all buat selama ni, yang sebelum ni adalah just identify or describe the instrument. It's not about hazard study. It's not about doing the hazard study. Okay, normally we will do that. Okay, we consider every single line. Okay, we consider every single line. For example, here. Okay, how did we come up? Before we answer the question, okay, we need to try to look at how that this structure was arranged. Okay, kenapa perlu ada both gate valves in front or at the back of your control valve? Okay, so the reason is because that you're doing the hazard study, hazard analysis for this stream. Okay, there is a few keywords. Okay, the variable is a flow rate, and you may have several keywords. Okay, for example, is what will happen? The keyword is no flow. No. Okay, the keyword is no, and the variable is flow rate. What will happen to this stream? Okay, this stream, if there is no flow. Okay, what will happen? The cause, the cause of this ataupun not the cause, sorry, the source, okay, ataupun the consequence. You need to first analyze in terms of the source. What caused no flow to this stream? Apa yang menyebabkan? Okay, apa yang menyebabkan flow ni? Okay, there is no flow, zero flow, no flow. Can you guess what? Apa yang boleh menyebabkan no flow? What caused no flow? Anyone? Physically, you will have no flow kalau physically, we are talking about physical of this pipe. Physically, you will have no flow if there is a breakage. Pipe tu tiba-tiba pecah ataupun patah. So no flow at all. Or total blockage. Tersumbat, so no flow. Okay. Or you punya control valve is stuck, fail to open. Maksudnya dia stuck, dia tak boleh buka. Fail, dia close, fully close. So no flow. That is the cause of no flow. Okay. So once you identify the source of this no flow, then you need to do how that this can be. What should be your action? What should be your action such that you can eliminate the no flow? Okay. You have several response over here. Clock. If you have a clock, you will have a less flow. Tom, if you have a clock. Blockage, yes, Irene, you may have 100% no flow if you have a blockage. Patah, pipe, block, leakage, you may have a less flow. If the keyword is less, then possibility that it's because of the leakage. Apa lagi yang boleh menyebabkan less flow selain daripada leakage ataupun clog? Clog pun boleh dapat 100%. I think clog also no flow. Okay. You may have because of your control valve is failed to close. You may have less flow because your control valve failed to close. Dia tak boleh nak tutup. Now opening, there is certain a percentage of opening, but since your valve failed to close, then you may have a less still fail to close and open. Thus the flow will be less. Okay, that is the keyword is less. And now for the no flow, so how do you want to avoid that? Okay, how you want to avoid that? That's the reason why every single control valve you need to have a bypass. Okay, every single control valve you need to have a bypass because of this possibility. Remember that hazard is possibility. There might be a possibility of no flow because of the stuck. Your control valve is stuck. Tak boleh buka. Okay, fail to open. So they stuck at the zero opening. So of course no flow. So if that happen, then you may manually open the control the gate valve over there at the bypass. Then you may bypass. And you have a bypass flow. Remember that this is a continuous process. You cannot have any discontinuation of the flow. Okay, because this is a continuous process. All right. That's the reason why you need to have a bypass, because of this heads-up study. Okay. The reason also why that you need to have these two control valve is disebabkan oleh, okay, that it's caused by the bypass also. How you want to activate the bypass? Okay, in order for you to activate the bypass, you need to have you need to open or close. Okay, open or close these two gate valves in between the control valve. Why? Because of this reason. Kalau no flow, okay, let's say if there's no flow, if there is no flow, then you want to bypass the flow. Therefore, you need to close the first valve. In this case, it's 0148. You need to close 0148. Okay, you need to close 0148 and also close 0149 because you don't want to have any flow go to that control valve. So you close dua-dua ni. Dan baru you boleh buka 0150. Then you will have a bypass. Alright. Then since this is a liquid, once you close 0148 and also 0149, then there is some liquid trap in between. Okay? There will be, okay? There will be some liquid trap over there. So you need to open the drain valve 0151 to empty that liquid trap within this control valve. So that is the purpose. Okay, that is the purpose. Since your control valve is stuck, okay, control valve is stuck, then you close 0148, 0149. Okay, you close, then you bypass, you open 0150, you bypass it. And of course, there must be some a percentage of the opening that is depend on the value given by the controller the previously. Okay, now the control valve is stuck. How you want to replace it? Okay, this is also about the maintenance. So you tak boleh buka terus control valve tu, sebab there might be some liquid there. Therefore, you need to open the drain valve first. Clean everything, make sure there is no liquid, then baru you remove and replace the control valve. Okay, the process cannot be stopped because it's continuous. Okay, cannot be stopped. Okay, that is how kalau you ada no ataupun you punya no flow because of the valve stuck. Okay, what happens if you have a high flow? Okay, you have a no flow, less flow. Now it's a high flow. Flow memang okay besar, very big. and that is beyond the ordinary, not the base value, the basic value ataupun the design value. So high flow, what happened? What caused the high flow? Okay, mungkin dia punya disebabkan oleh you punya control valve. We're just talking about control valve over here. Control valve to fail to close. It's already 100% open. Kalau they open 50%, you may have a less flow. But now it's fully open, but fail to close. Dia stuck, tak boleh nak close. Then you may have a high flow. So because of this, again, you need to do the bypass. Okay, you need to do the bypass. Close both valve, and after that, open the bypass valve accordingly. Okay, the opening. Then after that, baru you tukar. Okay, so that's the reason. Okay, the first question, there are two gate valves, both front and back of the Y. So you answer to ensure that no substance move into during maintenance being done. Okay. Almost there, but you don't give the reason why that you need to have both two. Kenapa kena ada depan dan belakang tu? Of course, you need to, this going to do during the maintenance. Okay, during the maintenance. Then you close those two valves. Okay. So we go to the next question. So what is the function of valve 0150? All right, 0150, I have mentioned that before, not before, just now. Act as a backup line to allow operating continue during the maintenance of shutdown to supplement the performance of the procedure reading valve. Oh, wow. Okay, please revise the answer. The answer is not that. That is not the exact answer that we want to have for this, because 150 is the gate valve for the bypass. So that is the purpose. Okay. When you want to activate the bypass, then you open the 0150 valve. Okay. How much? Depending on the set point given by the control valve. The control valve. Okay. Berapa persen dia punya opening? Number 3, what is the function of the drain valve? To remove the excessive water trap. Okay. All right. To remove the liquid. Yep. What condition that to activate? When the mainstream line has difficulties or problem. Okay. So your answer is very general. What kind of difficulties? What kind of problem? Okay. So normally it's because of the valve stuck. That's the reason why you need to activate the bypass valve. Okay, the bypass valve, because these two valve is already stuck. And not the control valve is stuck. Okay, so lebih kurang sama je korang ni, satu grup kan. Zuhairi pun sama, Azri pun, Azri? Mana figure Azri? Oh, right. Yeah, this is also the same. Right, this is also the same with the yang group tadi. Because of this, usually this is common because the valve always stuck. Control valve always stuck. Kalau you tengok the real control valve nanti, okay, hopefully that you may have this during your practical, during your hands-on nanti, kalau ada lah. So control valve ni memang kerja dia memang very hard. Okay. Within a second, memang ada several time closing and opening happen. Kadang-kadang dalam 1 minit tu banyak kali berlaku. Even 1 second kan, sometimes you can do 1 second open, 1 second close. Right? Then we expect that benda ni akan sentiasa akan sentiasa malfunction, akan sentiasa stick. You may have a sticky valve. Okay, it's not dia sticky, we call it sebab dia it's very slow, sluggish, slug. Okay, you nak buka a little bit slow, that's what we call sticky valve. Dia nak buka pun little bit slow, and then if that's situation, so reliability engineer will do some study, said okay, in 1 month time we need to change this into a new one, otherwise then it will stuck. Before it stuck, then you may see the dynamic performance of the valve. Okay, they might have some lagging. Okay, they might have some lagging. So you need to observe. Okay, but that's not tugas engineer ataupun tugas technologist. That is the job of reliability. Okay, reliability personnel or reliability engineer. All right. So you can the same discussion on that. Untuk yang ini lebih kurang sama saja. Adila 0088. So not what is your valve 0009. Banyak. Ada berapa grup yang dapat soalan ya? Ini pun sama juga Afrika. So all about control valve are the same. Alright. Haziq Zainuddin, grup mana? Tim mana? Where is your figure? Tolong letak otherwise susah nanti. Sama juga. Generico, please put the photo over there. Daniel, also put some photo. Let me check the comment. Ada juga. So the rest, please put some photo over there. Let me check. Whatever it is, please do put some photos so that we can discuss. Kat mana? Ini dah. Ini Ibrahim Khalil. Kita tengok yang belakang dulu. Elmira. Wow. Nampak tak? Okay, this is the light tank ataupun tank to temporary contain ataupun allocate this light component. Okay, temporary. So there is a first question. Now, what is the purpose of having LPS? What is the purpose for you to have a low pressure steam that coming into the jacket? Okay, into the jacket. This is just for you to hold that light component before you go to the main storage. To the main storage. You need to remember that having several buffer tanks, this is we call it buffer vessel or buffer tanks. In terms of operations, there are pro and also there is a con for this. Okay, pro and contra for this. The pro for this is basically you have since you have a holding tank, then you may have several value of resident time. Okay, several value of resident time. Then you may have some lag ataupun delay time for you to do whatever after this. For example, the resident time here is 2 hours. So the tank or the vessel will be 100% filled, okay, after the 2 hours. Then during the 2 hours, before the 2 hours end, then you can do a lot of things. Okay, what is a lot of things? That depend on the process. All right, that is the pro, but you can do whatever that required after that. Another thing is the con. All right, when you have this kind of vessel tank ataupun buffer tank, your dynamic process may have some lagging, some delay. Okay, having a lagging and delay in your dynamic system basically will decrease your dynamic performance. Okay, you may have easily kalau you don't, if you don't have this kind of vessel, so you don't have this 2 hours delay, then the process will become very smooth. Okay, otherwise you need to wait until 2 hours, then you may have then you may have another response to another process. Okay, but it's depend. Basically, this depend on your process that you want to monitor or you want to operate. For a process where you want to monitor several quality, several products with several quality, then the holding time ataupun the buffer tank is really required. All right, it's really required. Okay. The purpose of having LPS is to supply heat. Of course, supply heat, but why? Okay. The reason is because you have a light component. Okay, you have a light component over here. I don't know what kind of light component over here. In order for you to maintain that component at the liquid phase, okay, therefore you need to heat it up. Okay, you need to heat it up. Okay, so that's why the purpose. The second question, how to maintain the condensate without changing into vapor or liquid? A way that you can prevent the vapor from happening, the area is over here. Okay, this is the area where you can prevent your condensate to be back as a vapor. Okay, by the way, you have done your markup, and the circle instrument over here, what is basically the function? What is the name and what is the function of that roll? Not a roll, it's a ball shape of that equipment or instrument. Apa nama dia tu? You have done the markup last week, I think, yeah, last week. Anyone? Izwan? Tak dengar?
Boleh ulang tak clear.
Apa dia?
Boleh ulang soalan tak clear.
Yang bulat tu, apa nama dia? Kacau lah kau, Sofi. Benda bulat tu, what is basically the purpose of having that? What is the function of that thing?
Bulat separuh gelap tu
Separuh gelap, separuh cerah.
Tu gelap namanya self operating release buff.
Kau macam baca apa komen si Irene ni.
Tak, saya punya
Korang satu group ke?
lain.
Self-operating release valve.
Betul.
Self-operating release valve. Okay. Thank you, each one. You're just naming it, but what is basically the function? Sufi Huzaimi. Tadi kau sebut nama Izwan. Sekarang kau sebut nama kau.
Sufi.
Petik nama kau. What is the function of this self-regulated release valve? Tak tahu.
Dia macam automate, kalau contohlah ada perbezaan dari segi flow ke apa dia kan, nanti dia macam auto controlkan valve tu lah, dia sendiri, maksudnya bukan guna manual tenaga manusia macam tu kot. Mungkin lah.
Kau confident ya. Somebody want to help Sufi? Kalau tengok daripada nama self-regulated release valve. Okay. So how basically it function? Macam mana benda ni operate? Itu yang penting tu. Daniel, Sufi petik nama kau. Tolong dia. Mana Amir? Daniel. It's a self-regulated release valve. Release valve. Relief ke release?
Release.
One, release. Bukan relief ha?
Bukan.
Bukan. Okay. So what is basically how that this thing operate? When we are talking about self-regulated ataupun self-control, there must be something that you need to compare. There must be some comparison. Sama juga macam control loop. How we do the automated dalam control loop, because we have set point and we have something to compare. If it's not the same, then you need to do some action. Okay, so the same thing here. Okay, the same thing also here happened here in this self-regulated release, self-regulating release valve. What happened there? It's basically, remember that this is a condensate. As I mentioned before, that this condensate is quite not fragile, quite sensitive. Okay, quite sensitive. You may able to shift into vapor, easily shifted into a vapor, or easily can be a liquid or maintained as a condensate. So how to prevent it? Basically, okay, by having this, because the reason is, since it is quite easy to shift to the vapor, and also you don't have any utility ataupun in any heat related utility ataupun heat related unit operation that can change the phase. Therefore, you need to do something to reduce ataupun self-regulate, okay, self-regulate the pressure ataupun the vapor over there. Since nama dia self-regulated, meaning there must be something action will happen here. Okay, what will happen? You set a certain pressure here. There must be some standard pressure operating, and if there are vapor over there, that's why you ada dua benda tu, the dua section. There is a black and also the white one. Okay, the liquid and also the vapor one, the vapor section over there. Okay, and these vapor sections, it must have a certain maximum limit, allowable limit. Okay, the keyword is allowable limit of the pressure. So if there is more pressure, maksudnya what happen if there is more pressure? More vapor inside that valve. So you need to release. Okay, you need to release little by little. So that's why you call it self-regulated. Regulating, right? Self-operating. Ya, ataupun regulating. Release valve. More pressure, more vapor, then you may release them. Okay? Because you don't have any cooler that can transform this into a liquid. No. So the easiest way is release. Okay? The easiest thing is to release. Okay, there is one way to prevent it. My next question relate to this. So why that you need to have that bypass? Kenapa perlu ada bypass? Okay, you ada bypass valve 1074. Okay, 1074. Bila masa benda ni kita pakai?
Sama macam tadi. Lain.
Sama tadi tu macam mana? Tak sama apa Zuan. Tadi kita ada control valve. Sekarang ni kita ada self release ataupun self operating release valve. Bila masa you akan bypass? Siapa ada idea? Bila masa you need to bypass the valve? Remember that this okay, Luan.
Kalau benda tu problem, tak boleh.
Yelah, problem tu apa? Dia problem. Kan banyak benda problem. Macam Sufi tak menjawab pun problem juga tu. Contohnya. Apa problem dia? Penuh? Penuh, apa yang penuh?
Kalau penuh, tak boleh.
Ya, kalau penuh. Okay, kalau penuh. Kalau penuh, apa yang penuh? Liquid penuh ke gas yang penuh?
Gas.
Okay, alright. Kalau gas penuh, so what should be the action? Kalau gas penuh, what should be the action?
Release some gas.
Okay, Haziq, thank you. Yes, you can release some gas, some vapor. You can release it. Itu kalau penuh, kalau gas penuh. Kalau liquid penuh,
Bypass.
apa yang you bypass?
Bypass the liquid.
Bypass the liquid. Alright. How you know that the one yang you nak bypass ni adalah liquid? It's a condensate, right? Remember that this is a continuous, so make sure that whatever number of mole ataupun the flow rate for LPS, dia kena sama juga keluar as a LPC. When there is need to lower the pressure, pressure apa? Sufi, pressure apa? Sistem ni kita panggil low pressure system. Low pressure steam system. Ya, Sufi. What do you mean by lowering a lower pressure? Remember that di sini the pressure is not changing. We only have a low pressure steam system over here. Kalau masuk dalam ni adalah satu bar, then yang keluar pun satu bar. Dia takkan jadi bila kita masuk satu bar keluar jadi 10 bar. No, tak ada. So you cannot have some pressure reducing. Remember that yang masuk adalah steam. Okay, you have LPS. LPS is basically dalam bentuk apa? What is the phase of the steam?
Paper.
Vapor, right? So since you're vapor, then you release some heat, then it become, okay, you release the steam release some heat to this vessel, to this light apa nama komponen ni, bulat ni, light tank. Okay, so you release, then it's become condensate. Okay, dia bertukar fasa kepada liquid. Okay, dan bila liquid ni dah banyak, okay, ataupun liquid dalam you punya yang bulat tu, the ball valve tadi tu, self-operating, self-regulating release valve tu penuh, and you need to release it ataupun you need to change it. So in order to do that, then you need to do by some bypass. Okay, some bypass. Macam biasa, you close dua valve depan belakang tu, then you bypass, and you can do maintenance whatever, and you may reduce the liquid over there. Okay. When you're talking about release, sebab tu saya tanya relief ke release. Okay, sebab tu saya tanya tadi kan, siapa yang jawab, Izwan ataupun Irene tak menjawab, dia suka type itu. Okay, relief ataupun release. Okay, can you tell me, inform me, or inform us, apa yang kita selalu release? Pasal apa yang kita release ni? When you're talking about release, you're talking about which phase? Apa?
Release.
Release. The keyword is release there. Liquid. Irene say it's a liquid. Release liquid. Kan Irene. Apa lagi? Okay, when we're talking about release, if you have okay, let's take this situation. You have both liquid and gas in one container. Okay, in one container. When we talk about releasing something, okay, are you talking about releasing liquid or are you releasing gas or vapor? That's one thing that you need to answer. Shahira said it's a gas. Dan mana lagi laju? Or we're talking about efficiencies here. Which one is more faster? Releasing gas ataupun draining liquid?
Yes.
Release gas.
Okay. Release gas. Ada pernah dengar liquid release? Pernah dengar tak? Alright. So all of things are very important. Okay, so that's why it's a self-regulated to self-operating release. When you're talking about release, of course, the vapor the one that you can release it automatically, not the liquid. Tapi kalau liquid penuh, then you need to do maintenance. Okay, sebab why? Because you don't have the drain valve over here. Okay, if you look at the macam tadi yang first thing, kita ada example of control valve. So there is a drain valve, but in this case we don't have a drain valve. So kalau benda ni dah penuh dalam kit, then you need to activate the bypass, and benda tu you tukar ataupun you do the maintenance. Okay. Using the air eliminator. Apa benda air eliminator ni? No lah. You're gonna do that. Okay. The one thing that you may add, okay, the one thing or the one equipment that you may add here is, we call it steam trap. You can add a steam trap at the release there, at the drainage. Oh, you have a drain valve over there, but that is before the bypass. Okay, before the bypass. You may install a steam trap if you think that the LPS still there, is not condensed yet, that you can install the steam trap, because the steam trap tugas dia adalah to trap steam memang walaupun. Okay, you trap the steam, and once you trap it, of course they will close together. Once they close, the steam close, then they must have some energy release, ataupun dia akan share the energy ataupun the steam, and it can automatically condense into a liquid back. Okay, so this equipment is very important in dalam chemical plant, because in chemical plant you release a lot of steam. Okay, you are releasing a lot of steam, which is not energy efficient. It's not also economic efficient. So one thing to do that, one thing to save some energy, especially the water, then you get the energy, is you install the steam trap. Transform ataupun convert the steam into water. Okay. Yes, steam trap is easily can do that, but this installation is quite expensive. Okay, and the equipment also is not as simple as just like a control valve or just a valve ataupun the self-regulated release valve too. Okay, it's a little bit complicated, but yes, it's not also difficult to understand the process. Okay, so this is about this valve. Okay, kita pergi kepada Nur Hanani. Hanani, the process, pressure, temperature. Okay, PSB, mana PSB? Okay, PSB, right. The question asked over here is why that you need to have a PSB at the top of this cooler. Nampak tak? There is a PSB there. This is heat exchanger, not exchanger, this is a cooler, because you have mana TWS ah? Tak nampak TWS. Kat mana TWS? Ataupun you all potong TWS ni? Atau kat bawah lagi? Oh, sorry, ada kat bawah. Okay, sorry. Alright, you have that supply, tempered water supply goes to this heat exchanger, and then after that you have a tempered water. You know, essentially this is a water, this is a cooler, and you have a tempered water return. Okay, so in this case, if you look at this case, you have a water supply there, tempered water supply, and then once you cool it, then your water become hot. Okay, so your water become hot, and sometimes it might become some vapor. It might transform into a vapor. Okay, so what is the purpose here? What is the reason you have a PSB? What is the full name of the PSB?
Pressure safety valve.
You choose one.
You.
Nanti tengok si Irene, nanti dia tulis lepas tu nanti. Betul ke tak betul? Okay, PSB. And then after that, after the PSB, before returning into to the cooling tower, you have another drain, vent valve over there. Okay, there is another vent valve. So these two instruments basically for pressure. Okay, for pressure. To avoid that returning tempered water in the form of steam, the steam. Okay, we don't want to have that. So one way is by measuring first. Sebab tu you ada PG over there. But before that you have a temperature sensor. You measure the sensor, you measure the sensor, you measure the temperature. Since you know this is water, okay, since you know that this is water, and you know that what you cannot boil this one, okay, you cannot have a more than boiling point of the water. Okay. Okay, very simple question. What is the boiling point of water? Okay, kalau malu-malu nak cakap boleh just type. What is the boiling point of water? Very simple question.
100.
100 degree C.
100. Ketika kau jerit macam tu, ingat betul ke jawapan? Salah. Hundred 85. Dari kau, kat mana kau dapat 85 tu?
90 to 100 degree Celsius.
No, it's wrong. Lagi. It's not 100. It's not 85. Where's the boiling point of water? Hai korang ni, the final year. Dah pergi practical dah minggu next week ni. Next month. Lagi. Nuha, it's not 100. Wrong. One, mengarut lah kata one. 99.97. How you know it's 99.7? 97, 98.5 kan Zul? 89.
92.
Afika, what is 92? Alright, dah stop. Semua salah. Ingat ah? Nak masuk industri dah korang ni. When you're talking about boiling point, okay, boiling point temperature, you need to have pressure reference. Banyaklah infinity. You need to have a pressure reference. When you're talking about boiling point temperature, you need to refer at what pressure. 100 degrees C, yes, but at 1 bar ataupun 1 atm. At 1 atm, the boiling point of water is 100 degrees C. But it's not 100 degrees C at 2 bar. Okay? It's not 100 degrees C anymore kalau pressure dia berubah. Ya? So if you're talking about, if your answer is 100 degrees C, okay, it's totally wrong. 100 degrees C at 1 atm, yes, that's right. Or 97 ataupun 89 Degree C, add 2 bar, for example. Okay, that's right. Okay, boiling point need to have a pressure reference. Boiling point temperature need to have a pressure reference. Okay, all right. Don't make the same mistake nanti bila you all masuk industri nanti. Okay, that's why dalam case ni you need to refer kedua-duanya because that is we're talking about boiling point. So you measure the temperature and then after that you measure the pressure and then after that if there is a vapor exists, you already know because you already measuring these two. You're already measuring the temperature and also you're measuring the pressure. Then you may assume that ataupun you may have some clue that vapor will be formed. Okay, either vapor will be formed or not. Okay, if there is a vapor formed here, then the first thing ataupun the first safety that you may have over here, the safety equipment that you may have here is the PSV. Okay, PSV will release some of the ataupun release or venting some of the releasing ataupun venting some of the vapor. Buang macam tu saja sebab it's water. Tapi rugilah nanti. Okay, you might have tapi it's okay because the safety is more important rather than missing out of the losing some material. However, kalau masih ada lagi, you already release some of the vapor, then still ada lagi. That's why you have the manual vent valve over there. Okay, manually you can vent it out. Okay. All right. So that's why in this question we measuring temperature and also pressure. So that's the first question, I think. Why that pressure? Okay, itu dah. Because we want to prevent from having a vapor inside there. Venting, okay, because that is basically the second layer of the safety, the vent valve. Why that this system, you need to focus on the pressure and the pressure. I think I also mentioned this one also. Okay, because we are talking about boiling point here. Okay, so hopefully that we can answer that. Jacketed vessel Haziq, ini yang mana, sama tak dengan tadi? Bukan.
Bukan doktor.
So mana
Lain
gambar
sikit.
ni? Mana gambar ni?
Gambar dekat bawah.
Tak ada pun. Tak nampak pun kat bawah mana.
Ni dekat komen. Atas gambar tau.
Tu pun kau bawa hantar.
Saya buat hantar tadi.
Nampak tu dah. Kat mana kau hantar? Kau komen kat tempat kau tadi ke?
Dekat komen belah bawah doktor.
Tak ada pun. Kau baru komen ke tak kau?
Saya hantar dekat
Kau submit ke kau komen?
tong hantar. yang ni satu kan doktor, belah atas, belah bawah ni.
Ada pun mai dalam komen.
Yang ni doktor, saya try hantar lagi.
Ataupun kau punya kembar yang hantar. Haziq Zain.
Kembar saya dah hantar kat tadi.
Kau tak ada pun Haziq Zain tak ada pun hantar kat sini. Okey, tak apa, nanti kau ni double check lah. Okey, kita pergi kepada Syahira. Wan Syahira ni kadang-kadang dia mengarut juga ni.
Jangan bagi tahu orang doktor.
Oh iya ke? Alamak. Okey, kita besarkan sikit. Okey, nampak. This is about 2 lines of pump. Okay. Dalam gambar ni, dalam panel ini, usually we will have some backup pump. Okay, some operated pump and the other one is backup ataupun standby. The same concept we applied for for the other pressure related equipment such as compressor and also expander. When there is pressure related equipment, you need to have at least one standby. But this is not happen to temperature based ataupun temperature related equipment. Dalam temperature related equipment, kita tak ada pun ada standby heater ataupun standby cooler. No. Why? Kenapa pressure related equipment kena ada standby, whereas temperature related equipment tak perlu? Siapa bersuara tu? Khairul Zakwan. Ya.
Mahal kot tu.
Mahal. Apa yang mahal?
Means kalau macam buat double heater macam tu lah.
Mahal. You're talking about money now. You're talking about the cost.
Kos.
Okay. Kau ni not really answering the questions. Anyone want to help Khairul Zakwan on this? Why that you need to have? Always having a backup for pressure related equipment, tapi untuk temperature related equipment tak ada pun, tak perlu pun. Nothing related with the cost. Okay. Let's consider something like this. Apa dia? Safety. Kejap. Razik Zain, kau letak komen kat mana? Kau punya submission ke ataupun kembang kau punya submission? On dah mic tu, Razik Zain. Okay, nanti aku tengok. Kau lambat. Kita tengok ini dulu. Kenapa pressure related equipment kita kena ada backup? Whereas temperature related equipment no need to have a backup. The reason is not because of the temperature is quite expensive, no. Okay, and it's not also because of the safety, Kenzo, it's not about the safety. The reason is because when you're talking about pressure, is there any utility that you can use to increase or decrease the pressure? Is there any other equipment rather than pumping, rather than pump, rather than expander, rather than compressor that can help you in increasing or decreasing pressure? Ada tak? That equipment itself. Sebab tu you need to have a standby. You need to have a backup for that equipment. If you want to increase the pressure of the liquid, therefore you need to pump it. You tak perlu pun ada any help from other utility ataupun from other equipment. You use pump to increase the liquid pressure. Okay. The same thing also, if you want to increase the pressure of the vapor, of the gas, then you need to compress it. Compressing the gas will increase the pressure of the gas. Okay. Sebab tu, all of this require some backup. Kena ada backup. Sebab equipment itu sendiri yang increase or decrease the pressure. Whereas for the temperature, tak perlu ada. What you need? What do you need? What kind of equipment that you need in order for you to increase temperature? Apa yang you perlukan? Apa dia? Sarul?
Heater.
Heater. Okay, heater is equipment. What
Steam
can
vessel.
you need to have a heating related ataupun heating utility. You may need to have a steam. And the efficiency of maintaining temperature or increasing temperature or decreasing temperature bergantung kepada you punya utility. No need for you to have another heat exchanger ataupun another heater. Berbanding dengan temperature, berbanding dengan pressure, compared to the pressure related, like a pumping, like a pump, a compression, also expander, alright, that equipment itself yang increase or decrease the pressure. Sebab tu you need to have a backup. Kalau satu rosak, then you need to bypass it to another one. Tapi kalau cooler ataupun heater, you cannot achieve the temperature of your desired stream, of your desired process, you tak perlu pun tambah lagi another one. You just increase your flow rate of your steam ataupun flow rate of your cooling water or of your coolant. So, okay, it's not about expensive or not, Harold. It's about benda tu, you have another one, you have another process that can help you to increase or to decrease it. Okay? So that's the reason why that you need to have a double of the pressure related equipment over here. Okay. Then there is a one question here. So you have they call this process line and also the bypass. So in this case, which one? If you look at this, yang mana akan you panggil ataupun normally you will start first during the startup, line mana yang you akan pakai? Line process line ke ataupun bypass line? Apa yang dorang jawab ni?
Dan Zarif.
Okay, the question it was, not was, the question still is. Okay, the question is about these two lines. You have a process line, also the bypass line. So usually during your maintenance ataupun during your startup ataupun during your shutting down process, apa yang mana usually you all akan guna dulu? Yang process line ke ataupun yang bypass line?
Proses.
Tanzul answer as a process, tapi Akmal cakap bypass. Mal, kenapa why that your answer is bypass? Okay, alright. Akmal, kalau you tengah buat shutdown, when you are shutting down everything, bypass pun tak pakai dah. Sebab you are shutting down. Okay, you are shutting down. Semua akan tutup. And then semua akan close. All those valve yang you ada sekarang ni, either is a glove valve ataupun you punya gate valve, during your shutdown operation, all will be manually closed. All those valve will be manually closed. Okay? Including the control valve. Control valve pun will be turned into manual action. Sebab you not shutting down. Yang you akan pakai bypass bila you buat maintenance of the process line ataupun process pump. Okay? Bila you nak buat maintenance saja. Ataupun tiba-tiba you punya proses pump tu, process line tu, dia punya performance, dia punya efficiency little bit lower. Okay? Little bit lower. Ataupun dia punya reliability, we're talking about reliability. The efficiency, we're talking about reliability. Little bit lower, therefore you need to close that for you to do some maintenance, and then because of that, then you akan guna the bypass pump. Okay? Alright. Satu lagi, a quick question ataupun quick quiz. Apa kaitan? Okay, we are talking about pump. We're talking about pump efficiency. Okay, we're talking about pump efficiency. What will happen if you operate? Kita ada dua sekarang ni. Kita ada PG, what's the name of this pump? You have 0263. Yang atas tu berapa? 1083. Okay, we have these two different pumps. Dia punya numbering pun tak sama. Okay, you ada bypass, ada 110, 110 pula, 1083, whereas the process pump kita ada 0263. Okay, usually when we start, this is sepatutnya lah, this is how you do the numbering. Usually you will start with 0 for your process. Okay, and the one with the starting number 1 ataupun starting number 2, usually we call it backup. Okay, the first backup, the second backup. That is how you do the numbering. Okay, what will happen sekarang ini? What will happen? You have a first valve and you have a pump and you have a second pump. Though these two pumps operate at different efficiency. Okay, we call it adiabatic efficiency. You have a different adiabatic efficiency. The process is about operated at about 50% efficiency, whereas the backup pump operate at 75% efficiency. Okay, backup ataupun bypass, backup lah, ini bukan bypass. Backup kita ada 75% efficiency, adiabatic efficiency, whereas the operating one is about 50% efficiency. Okay, so in terms of energy usage, which kind of pump that you think is ataupun, okay, it's not the question. Okay, kita tukar soalan dia. You ada efisiensi 50% dan yang backup kita ada 75%. Which pump, in your opinion, when you operate it, will increase the outlet temperature? Oh, sorry, both basically will increase your outlet temperature. But which one will give you the highest one? 50% ataupun 75%? We're talking about pump. We're talking about pumping process. Okay, yang biasa kita ada 50% and the backup kita ada 75%. So which one do you think will have the highest outlet temperature? 50% ke ataupun 75%? Jawab sekarang. Lepas tu baru saya explain kenapa. Anyone? 50 or 75? Itu je jawapan dia. Just type dalam chat 50 ataupun 75. Maksudnya yang okay, those yang you bagi answer dia the 50 ataupun 75, that basically will give the highest temperature, outlet temperature. Mana? Hebat. Ataupun korang tak pasti mana satu. Dua-dua akan okay, both will increase. Both pump will increase your outlet temperature. The question is which one will give you the highest outlet temperature? The one with the 75% efficiency or the one with the 50% efficiency? Isaac Iza 75. Kembar dia Isaac Zen berapa pula? Isaac Zen apa salah kau sebut is pula? 50. Akmal, 75. Kanzul, 75. Aziz Iza, more faster and thus prevent itu justify tu. Azhar pilih 75. Korang ni mentang-mentang 75 tu besar, kena ingat temperature pressure dia akan tinggi lah. We are talking about efficiency now. Generico 50. Lagi? Sophie. Kau sebut pula nama Sophie is one. Is Koyum mana? Dia ada tak hari ni Is Koyum? Inilah. Malas nak mention C1 ni. Itulah dia punya perangai tu. Dia punya code tu memang dia jenis yang tak pasti sangat. Kan tekan tu Iwan. Okay, bahaya sikit kalau korang nak rapat dengan Wan ni. Dia ni mudah lupa ingatan. Okay. When we are talking about pumping efficiency, we're talking about transferring. We're talking about transferring the mechanical, which is pumping. We're talking about pumping up. Pumping is a mechanical energy. You're changing from the mechanical energy into the heat energy. Okay. Remember that energy, law of the thermodynamic. First law of thermodynamic. Energy neither created nor destroyed. Okay? You cannot create energy, or you cannot also destroy energy. But energy can be transformed into another form. So in this case, we have a mechanical energy. You transform it into a heat. Okay, pumping is a mechanical. You have an energy there. You pump it, okay, by rolling it. Your pump adalah cara dia tu, and then you will increase the pressure. If your pump is very high efficiency, okay, very high efficiency. Remember that bila mechanical things ni dia tengah operate, okay, machine, right? Besi dengan besi. Then what happen? Okay, what happen kalau you tumbuk ataupun you ambil tukul, then you tukul is a besi, then you tukul pipe yang besi juga. What will happen? Okay, the energy will be transformed into heat. Okay, so pumping is a mechanical thing. So there will be heat release into a heat converted from the mechanical and transfer into outlet stream. Okay, as I mentioned, both will increase the temperature. Tetapi those with the lower efficiency will have more, or will have higher temperature compared to the high efficiency. Okay, so jawapan dia adalah 50, because 50 is the lowest efficiency. So most of the energy will be converted into heat. Okay, will be, sebab is less efficiency. Sebab tu, if you have a less efficient pump, energy akan banyak terbuang kepada jadi heat. You will lose energy in the form of heat, since you neither cannot create nor destroy the energy, but it can be transformed into another form of energy. So a lot of energy will require at the lower efficiency pump, since most of that will be converted into heat. So kalau you nak jimat, if you want to have a less energy requirement for your plant, make sure that you always check your pump efficiency. Okay, sama juga dengan compressor dengan expander. So tugas reliability, let's say lah, mana tahu in the future you become a reliability engineer, so always operate ataupun always use your high efficiency pump. Okay, kalau dia drop lah, then tukar, otherwise you will lose a lot of energy. You may use a lot of energy. Okay? Alright. So one way nanti bila you pergi kepada industrial training nanti next semester, so make sure that you go to the pump room, then check what is basically the efficiency of each of these pump. Okay. And after that, recommend that always use the high efficiency one, although it's quite expensive, but when you compare with the energy saving from that, more you can save rather than just use the low efficiency pump. Okay? Alright, jangan happy sangat lah. Qayyum, kau jawapan ni teka je pun. Okay, kita pergi kepada next question. Keempat kita stop. And you can do the correction of this within your team. Hairul Zakwan, mana kau punya tu drawing? Tak ada. Haziq Zain, kau cakap kat tempat komen tadi. Ya, Hairul Zakwan, ada apa-apa kena cakap?
Saya sama dengan ni, dengan Haziq.
Okay, Haziq mana? Haziq Kembor.
Haziq Kembor.
Kau tak ada Kembor.
Dua-dua ada tu kat komen. Tu yang baju merah tadi.
Merah? Siapa baju merah? Ni. Kau satu grup ni rekod ke apa?
Aziz Zain. Atas sikit.
Atas sikit. Oh.
Tu lah tu.
Oh, dia pakai spek hitam ni.
Macam mana tu?
Aduh. Noha, komen Noha. Noha tak dengar suara gini. Mana kau punya sistem? Sama je ni dengan yang tu.
Iskoyum tolong postkan tak tu? Yang tu.
Yelah, rasanya kita dah explain yang tadi yang apa, yang geng perempuan tadi, siapa? Hanani ke? Bukan Syahira. Yang ini, Elmira. Sama dengan Elmira tadi. Jangan risau, yang ini saya record lah. Nanti you boleh check balik recording. Okay. So you all punya ni lebih kurang sama saja. Jacket vessel. About jacket vessel. Okay. So Hairul Zakwan kalau sama dengan si Amir Daniel sama juga kan. Generico pun sama juga ni. Aziz Zain pun sama. Ini apa ni? Afika pun I think we have explained on this control valve. Adila pun control valve. Izwan Syami kita dah discuss ni kan? Yes, we have discussed this. Hilman pun sama, Hilman. Zuhairin Asman pun sama, we have discussed this one. Ada yang baru hantar tak? Azri pun baru hantar tadi. Sama juga control valve, I think we have explained this one. Ibrahim Khalil, apa dia kena tunjuk ni? Asal pecah ni. Okay. Aku rasa lapar bila tengok, bila baca sandwich tu. Ni dosa kau Khalil. Ibrahim. Sufi, this is okay, lebih kurang sama juga. What is the standard operating procedure? Okay, we have covered this one. Okay, tadi dah. Okay, alright. Kita tengok inilah. One thing yang I need to address over here that the next, I think untuk startup procedure, shutdown procedure, everything need to be referred to one single diagram. Okay, alright. Ingat untuk startup procedure, shutdown procedure, operating procedure, sebenarnya saya dah ceritakan, dalam operation ni kita ada 3 fasa ataupun kita ada 3 stage. Okay, startup stage, kita ada operating stage dan kita ada shutdown stage. Ketiga-tiga ni memerlukan only one single diagram, which is PNID, Piping and Instrumentation Diagram. Okay, tak perlu pun process flow diagram, tak perlu, because process flow diagram you only have less information, tak banyak pun instrumentation ada dalam tu, tak banyak pun alarm dalam tu, tak ada, none, basically memang tak ada pun. Okay, sebab tu it is important for you to able to read, and not also read but you understand, and you're able to justify why that we have sandwich verbs. Sandwich si Khalil lah ni, si Ibrahim Khalil lah ni punya kerja ni, sandwich ni. Okay, why that you need to have that kind of structure, that kind of configuration? Okay, you cannot see this one in the PFD. Of course, you cannot see this kind of structure dalam PFD, only in your PNID. Okay, that's why this thing is very important for you to understand it. So we have rasanya dah lebih 2 minggu kan kita buat ni. Okay, tengok the real PNID and how that you come up with the markup, the individual instrument, the verb, some of the instrument yang you tak pernah tengok selama ni pun, pipe fitting pun tak pernah tengok selama ni pun, you can see that. Alright, so that is most important thing that you need to learn in one single PNID. Basically banyak lagi kita tak tengok lagi prosedur macam mana kita nak buat safety, nak tengok safety belum ni, kita tak boleh tengok pun belum. Okay, untuk benda ni kita just concentrate on the operating. Okay, on the operation, we just look at the operation. What will happen in order to make your smooth operation? Since your control valve is stuck, then bypass is always be there. Okay, bypass is always be there. Bypass juga you boleh nampak dalam control valve. Not control valve, of course control valve yang macam ni. You also can see the bypass in your pump. Ada gambar pump tadi itu si Hira. Kenapa tak ada bypass? Oh, sebab dah ada itu backup tu, sebab tu itu dia punya bypass tu. Okay, tak apa. Okay, another thing that you need to take care adalah tentang alarm. Alarm system. Alarm is part of the safety instrument. Okay, and this alarm only can be monitored in the control room. Sebab tu kalau tengok instrumen sensor yang dengan alarm ni adalah sentiasa dia dalam kotak, within the box. Dan dalam tu, dan itu you akan tengok dalam box tu akan ada 2 types of alarm, high dengan low alarm. And from that we know that which variable which is very important. Kalau dia ada banyak layer, so that is very important variable that you need to monitor. Okay, kalau dia cuma ada satu high alarm and low level alarm, low alarm, so benda tu is not really important. Okay, especially on apa yang biasa flow. Selalu flow kita akan cuma ada high, low, ataupun jarang ada low, jarang ada high, selalu low saja. Because we don't want to have a no flow. To avoid to have a less flow ataupun low flow, then you need to monitor the low flow. Okay, and set an alarm for that. Okay, jarang flow kita akan ada high alarm. Okay, selalunya high alarm ni kita guna untuk level. Okay, untuk level. Kalau ada pun the flow maybe easy, okay, easy to have, okay, easy to have a high flow. Tapi jarang lah benda tu. Okay, selalu kita akan ada low ataupun low, okay, low ataupun low alarm untuk flow, which is low alarm to prevent the less flow to happen, and low alarm used to prevent the no flow. Sebab kita ada dua keyword dalam flow rate. Kita cuma ada selalu kita akan take care on the low alarm for less flow, and low alarm untuk cater no flow. Okay, alright, so almost 4. So what I want you to do now is based on our discussion. Okay, and I will stop recording also after this. Tapi jelah mungkin dalam 1 hour baru boleh dapat dia punya copy, but it's okay. Based on our discussion just now, so I would like all of you to go to your individual room, a breakout room, and discuss. Okay, discuss and put some comment at your submission, especially on if there are any correction that required, or is there any further explanation required, then you need to put it there in your comment. Okay? Okay, boleh ke tak?
Boleh.
Okay. Take 5 until pukul 4 baru boleh masuk dalam breakout room. Okay. Penghulu boleh bagi lagi list link untuk tu. Okay. So minggu depan you all akan start face to face dengan Dr. Aziz, Dr. Haikal.